Hello, this brief video recording is about the text I have in Canvas under the tutorial section of the file folder, which says instructions or guidelines on how to develop sequence diagram. We have already spent 1 hour each group by analyzing one of the sequence diagrams from the group from the book. However, I would like you to read these couple of bullet points. It's just 1 page of the text to summarize actually the role of diagrams in the process of modeling. I'm going now to share the screen with you in order to see what is in these bullet points, and would like to draw your attention to 2 things. We are here in principle talking about not a process which says do this, do that. We are talking about issues which are related to the purpose and the existence of these diagrams. And what you need to remember in general, there will never be a question in the exam which covers this. But in order to understand really what its purpose is, you must be familiar with these bullet points, which are numbered here. Okay, the first bullet point says that you must make sure that you have a clear explanation of the basic principle, what the role of sequence diagram is in software modeling. And you know what their purpose is. So what would be the purpose? What could we conclude from our workshop last week, what the purpose of the sequence diagram is? It's quite important because it addresses functionality which has been defined in use case model. So the use case model is a starting point for drawing sequence diagram. And please be aware that UML was done many years ago in order to develop software solutions, software intensive solutions. That means software involved in every single part of your solution, so that you do need a computer program at the end. That's your final goal. So if you are using sequence diagram for anything else, then you do have to think about that. Just the fact that you are developing software and sequence diagram must show exactly that software product will be designed according to the meaning stored in sequence diagram is very clear. So if you don't have a software artifact in the abstractions of the sequence diagram, you are not developing software systems. Okay? What can be anything else? But it's very difficult in today's life that we have a strict barrier in between something which is physical and you can see, you can live with it, or something which is not, and we call it as abstractions or software artifacts. Very, very difficult to make a strict barrier in between the two. So anything else needs debate and thinking. Number 2, they are always created from the use case model, skipping class diagrams instantly. Okay, so you pick each use case you have in your use case model and you try to develop a sequence diagram. However, as it's underlined in point 2, you need use case description. These descriptions are essential. We usually don't have them in our short workshops, but in the exam you will have them. In the assignment you will be able to develop them. In real life you will have to write down use case descriptions in order to find out all the abstractions which are being important for creating sequence diagram. So be aware that include and extends in the use case model must be shown in sequence diagram. If you have include two use cases and there is include connection between them, stereotype dependency between them, then these 2 use cases must be shown in one sequence diagram. I'll give more information on how to do this in the next couple of video recordings. Okay, but if you have exceptions like extents, then you may be able to draw two separate sequence diagrams, one for the main base use case and one for the use case which extends that main one. Okay. Now, in software development, these abstractions have an extremely important role. Abstractions that you discover, particularly in the top row of your sequence diagram, they are essential part of your software artifacts. So if you manage to find software artifacts which belong to the top row, you are resolving 50% of semantics of sequence diagram. So there is another thing which is very important there. These are the messages between these abstractions, which we call objects. So messages pass between, which are detected in between objects as time passes. So these are two important things. Objects at the top, which will be future part of your software application, and messages pass between them. We still cannot talk very much what's the purpose of these messages pass between them, but there are various ways of using them, these messages in software development, so that they will play different role using different software technology for implementing solutions. But in principle, in object orientation, passing messages between these two objects are very well defined if your implementation will be done using object-oriented programming language. If your implementation is related to database management system or related to any other deployment of any other environments where you use some other software technology, not necessarily object-oriented programming, then these messages can have slightly different format and different role. So that means that the existence of sequence diagram does not guarantee that you will have object-oriented implementation using object-oriented programming languages. No. It is a universal diagram which doesn't specify which technology is going to be used, which programming languages, and which way of storing data and computing upon data. None of this can be defined in sequence diagram. These objects on the number 4, objects which are at the top row of your sequence diagram are quite easy to remember what you should have there. You need user interfaces, you need your computer program, which is called controller, and at the end, you need a lot of data objects which are used for performing computing with that controller. So we cannot debate that. This is what the UML philosophy says. So for the first two objects, you are very sure that you know what you are doing. If you put user interface and the control object, which is your computer program, that's a must, and it's based on the use case that you are converting description into a sequence diagram. Okay. So for these two, you don't search for them. You're just putting them at the beginning as we speak. But for the others, you need really to go around your use case description and find all data objects which are necessary for computations. Okay. Now, it is very difficult to give a more specific advice for that, because a sequence diagram always depends on the nature of use cases. So what is in the use cases determines the destiny of the sequence diagram, and can be really different from use case to use case. So you cannot just give a strict guidelines how to do that. But your sequence diagram should pinpoint the main software parts which would guarantee that the functionality defined in the use case will be delivered through the software application. Okay, so it's kind of kind of guaranteed by the sequence diagram. So if you are following strictly UML rules and have initially user interface object at the top, controller second, you cannot fail short of showing software solution. You can only be a little bit short of data objects in the computing, but they can be discovered even after you create a sequence diagram. Very, very often this may happen. The source of information, again, is always the description. I'm reading number 6, description of use cases. This description can, if you are not very pedantic and you don't want to write it, or your description is only in your mind or debated around the table, then you can always change your mind of which data objects are relevant in this particular sequence diagram. But you will never, never be able to change your mind on the existence of user interface and control object. This is not something that you can debate about. At this stage of the development, do you see, you are supposed to have only one controller program in one sequence diagram because it mirrors a use case model. And use case model has use cases, so each use case is one sequence diagram. So it would be unusual that you have 2 controller objects in a sequence diagram, or maybe not. What about include? If you have an include, then the drawing of sequence diagram becomes really complicated. There are various methods of doing that, and unfortunately, not a single book shows any of this. There is actually not a book which writes these bullet points. This is why I wrote them, because you can't just open any book on UML, on the UML where these things are spelled out, 1, 2, 3, 4, 5, 6. Okay. So why do you need this 1, 2, 3, 4, 5, 6? Just to tell you that you need to bear them in mind. In the exam, you can just simply read them if you are uneasy about discovering object and messages in between these objects in sequence diagram. But that's the purpose of that. So the purpose is get me objects which will become part of my software application, and this object must contain data object, and let's define messages passed between them, bearing in mind that the first is user interface object, second one is your computer program. So messages don't jump around just like that. So computer program is the one which can send messages all over the place, and user interface can send message to a computer program, receive the message to the computer program, but data objects cannot talk to each other and send messages in between them. No. Okay. There is more, but this is mostly done for people who, for any reason, missed our sessions on sequence diagram in the last week. So please listen to this and try to get familiar with this philosophy. It's just philosophy of UML. I can't describe it better. This is what they wanted 25 years ago, and that's it. No definition of which technology is being used there, no. And no assurances that you will implement this in C++, no. But you may have. Thank you. I'm now going to stop sharing and close this video recording. Thank you for listening.